Seeing What's Missing, Visualization of Incomplete and Imputed Data by Hanne Oberman from Utrecht University, here today for the Rainbow R Conference 2026. As you probably know, R is quite strict about missing values, or NAs. If there is just one missing data point, many functions will return NA too. And statistically speaking, that is correct. The mean here is undefined because of the missing value, but it is also obnoxious. That's why people typically add na.rm, remove any missing values in this function call. And a lot of functions do this for you by default, actually, such as in the visualization package ggplot2, ignoring any missing values. And this works. It is quite convenient to ignore incomplete rows. But if there's a lot of missing values, it is very wasteful. And more importantly, it assumes that the data that we do have is completely representative of the population that we may want to extrapolate to. And that is not always the case. For example, when in a clinical trial, people drop out due to side effects from the treatment, we might end up overestimating the efficacy of our treatment. So complete case analysis often leads to biased results. And we don't want that. Unfortunately, missing data are quite a pervasive problem, but I'm here today to convince you that they are visualizable, analyzable, and sometimes even informative. And of course, we'll be using R for that. Data wrangling with dplyr, visualization with ggplot2, and then the combination of the missing data packages mice and ggmice. Mice is for the imputation or filling in of missing values. And ggmice is a wrapper around ggplot2, but it does show missing values. As a case study, let's create some fake data. R use, the frequency that a respondent might use R in days of the week, and happiness, where most people on a scale from 1 to 10 are pretty happy. And if we would have had complete data, we here see the happiness by the use of R. There is an association where the more you use R, the happier you are on average. But what if I told you that we did have someone who uses R every day of the week, but has not replied to our question about happiness? We have a missing value. Can we then just ignore this person? Well, we already know complete case analysis is often biased because this person might not just be as happy as the other people. There might be maybe a tipping point at which you become less happy if you use R every single day of the week. But there's a missing value, so we don't know. So what could we do? We could use the observed data to figure out what the plausible values might be for this incomplete case. And if we would impute this predicted value, then we would have a perfect prediction along the line of the observed data. But unfortunately, this would end up with incomplete results because we're underestimating the amount of uncertainty here. That's why we should do it multiple times. Use the observed data points to figure out what a range of plausible values might have been for our incomplete case. That way, we can reflect the appropriate amount of uncertainty in any analysis that you run afterwards to reflect how uncertain we are about what this missing data point might have been. And sometimes a missing data point is actually informative of the data at hand. If you would ask me the question, what is your gender? But you would only provide me the answer options, male or female, I would actually be a missing value in your data set. So sometimes missingness shows us that our data collection is not appropriate for the lived experience of our participants, for respondents. So I hope you learned today that missing data are not just pervasive, they are also visualizable, analyzable, and sometimes even informative. Thank you very much.